We're beginning many of assignments on antidifferentiation and integrals, so I'll quickly repeat some of what you've already heard in class. These two problems in question 1, notice, differ only by a constant, so they will have exactly the same derivative. So it is possible for different functions to have the same derivative, and the phrase you should be able to repeat is, if two functions differ only by a constant, then they have the same derivative. So when we start the process of antidifferentiation, when we are given the derivative and we say, where did it come from? When you reverse the power rule, you would add 1 to the exponent, and then you would take your coefficient and divide by that new exponent, and you'd say, well, that's not the only function. It could have any constant. So we get a family of antiderivatives. So repeating the process, here's an f prime polynomial. So what do we know about the function that has that derivative? Well, one by one, we do the antiderivative of each term, raise the exponent to 3, take the coefficient and divide by 3. In the next term, raise the exponent to 2, take the negative 8 and divide by that 2. In the third term, the x to the 0 power, let's raise it to an x to the first power. And then we add our constant of integration, so we get a whole family of antiderivatives. All right, so in this problem 3, we do not know what c is, but in question 4, we add another layer to the problem, and we are told that when x is equal to 0, y should turn out to be 7. So this is an initial value, and we can substitute those coordinates for x and y, but hopefully you quickly will recognize that this is the y-intercept. 7 is going to be the value of c. Let's make sure that's clear to everyone. The y-coordinate, f of x, turns out to be 7 when we put 0 in for x. So I certainly do not want you to write this arithmetic, but does everyone see very clearly why the c value is the y-intercept of the problem? So when we're given f of 0 equals 7, in your homework problems, you would immediately substitute that in for the value of c. So if we're given an initial value, we can find the constant of integration. So now we say that we have one specific solution or particular solution. So instead of a family of antiderivatives this time, we know the specific or particular solution. How could we give a more precise answer? Given an initial value, every single time you're given an initial value, you use your algebra, substitute x and y coordinates to find c. The constant now becomes a specific value. All right, so a couple important terms here. An indefinite integral does not have an upper and a lower limit. So an indefinite integral is really just asking you to do the simple process of finding the family of antiderivatives. So here we would say sine is the derivative of what? So sine is not the derivative of cosine. It must be the derivative of the opposite of cosine. And then we would add a constant to it. You've already seen some practice in your computer lab with definite integrals. Once we add a lower and an upper limit, then it becomes a definite integral, and we're going to do some theorems in the next assignments about that. So the process of integration involves finding an antiderivative. All right, so when you are given an integral, the term behind the integral symbol is the integrand. So if it is given in radical form and you want to reverse the power rule, remember to change roots into exponents. And then to reverse the power rule, we added 1 to the exponent, and then we divided by that exponent. So to divide by a fraction, of course, you'll multiply by its reciprocal. And we can only find the value of c if we have an initial value, or here I used another term, an initial condition is the same as an initial value. All right, so in these practice problems, I included derivative and integral to make the point, because it's very frustrating, especially with the power rule, if you move your exponent in the wrong direction. So the derivative of x squared is, of course, 2x. So now look at what's familiar here to us. When we integrate, we do the antiderivative. So this x has an exponent of 1. So for the antiderivative, we would raise the exponent to 2, and then we would take our coefficient of 2 divided by that exponent. So you don't have to think about that at all. When you see the 2x, do you say, oh, I already know that 2x is the derivative of x squared? So similarly, in question 6a, the derivative of cosine, you know, is the opposite of sine x. So when you look at this integral, you say, well, cosine is the derivative of what? So cosine is the derivative of sine of x. And then don't forget to add the constant of integration. So we get a whole family of answers. The derivative of 5x is, of course, 5. So that tells us what to do with the integral. Now you reverse your thinking and you say 5 is already the derivative of what? So it came from 5x plus a constant. The derivative of the natural log of x is 1 over x. And remember that we might need a restriction here. So think about whether your domain is x greater than 0 or not. Depends on some problems. And here, this x cannot be 0. So remember, we have to stipulate that. So if we're given that x is a positive number, then 1 over x is the derivative of what? So if you know your derivative rules, then you know how to integrate. So you'd say 1 over x is the derivative of what? It is the derivative of the natural log of x plus any constant. All right, let's continue with some more homework problems. And you can zip right through these. You need not show any work. So the derivative here is a power rule. So 6x to the 5th. To integrate, I reverse the power rule. So I want to raise that exponent to a 6. My coefficient used to be a 1, so now I divide that by the 6. And I add a constant. The derivative of tangent is secant squared of x, so kind of gives away the answer. So for 10b, you're saying secant squared is already the derivative of what? It is the derivative of tangent x plus a constant. In 11, the derivative of a sum is the sum of the derivatives. So we do power rules on each term. So 3x squared plus 2x. So the derivative of a sum is the sum of the derivatives. So how about integrals? The integral of a sum is the integral, or the integral of a sum is the sum of two integrals. So we're not going to bother writing this, but to make the point here, could we split this up into two separate integrals? And if we were that precise, we would add a constant when we do each of these. We would add a constant to each of these antiderivatives. But what would happen then if we later combine those constants? Wouldn't the sum of two constants still just be a constant? So we're going to, instead of doing two separate constants, we'll raise this exponent to a 3 and divide by it. We'll raise this exponent to a 2 and divide by it, and we'll just add one constant. So when you are given the integral of a sum, you need not split it up. You can just do the antiderivative of each term. All right, so if you remember your derivative rules, the derivative of arctangent, 1 over 1 plus x squared. We don't need a chain rule since that's just a 1x term. So now the important thing is that you need to know that rule well enough to recognize it by observation. The integral, you'd have to see this and say, oh, that looks familiar. That is the derivative of arctangent. Not tangent, but arctangent. And don't forget to add your constant. All right. Reversing the power rule here. I'm going to bring down the 7/4 and subtract 4/4, or 1. So here I'm going to change the integral to a power rule, and it's a little different, x to the 2/3. So to reverse the power rule, I'm going to raise that exponent. So I'm going to add 3/3, and the coefficient was 1. So now I'm going to divide by that exponent. So that's going to be a 3/5, and we add a constant. In 14, the derivative of cosecant is negative cosecant cotangent. So when we look at this integrand, you'd say, oh, well, that's not exactly right because it's missing the negative sign. So how can we compensate for that? What is this the derivative of? It must have had a double negative. So what if we had this be the derivative of negative, or opposite of cosecant x? So think about it. If you did the derivative, would you get back to the integrand? And then we would add our constant. So you might have to compensate. If you needed a negative, put one in there so that your two negative signs would become positive. Derivative of e to the x is e to the x. So the antiderivative of e to the x is also e to the x. We like exponential functions in calculus. The derivative of cosine, of course, is the opposite of sine. So sine is the antiderivative of, so we want to do, sine is the derivative of negative cosine. So let me get that out of there. So there again, check it out that we're compensating here so that when we do the derivative of cosine, we would get the opposite of sine, and then the opposite with the opposite would cancel out to get us back where we started. All right. Inverse sine, the derivative is 1 over the square root of 1 minus x squared. No chain rule needed on this problem. So now again, are you going to recognize when you see the integral, are you going to say, oh, that looks familiar? This is the derivative of arcsine. So you can only do integration if you know your derivative rules really well. And likewise for arc cosine, the only change is a negative. Probably want to put that out there. So when you recognize this integral, you'd say, oh, that's the derivative of arc cosine. Add a constant. All right. So where we're headed in future assignments is they won't quite be all that easy. So let's look at this integral. Cosine of 5x. So can you see the layer we're adding? What about chain rules? So cosine of 5x is the derivative of what? Well, our first thought is that it's the derivative of 5x. But that's not true because there would be a chain rule if we did the derivative. So how do we beat the system here? Let's put a reciprocal there. So now if we did the derivative, would we get back to the integrand? And then we just tack on a constant of integration. All right, so see if you can do the same thing in 20 if you haven't already done that. So you'd say, oh, there's a chain rule here. So e to the 3x is not the derivative of e to the 3x. If we started with e to the 3x and did its derivative, we would bring down a chain rule of 3. So to compensate for that, what if we put a 1/3 there? So again, how do you check your integrals? You check your integral by differentiation. So differentiate and see if you return to the integrand. So you check your integral by differentiating your answer and seeing if you get back where you started. And we'll work on these as they get more complicated in the upcoming assignments.